Good afternoon, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. In this lesson, we go into statistics. I just came through this question as I was looking at what I'm going to teach my students. This is Math 4, should be Math 461. 461 at Florida College of Education. No, should be Math 461 or 462. Don't know the code, but this is statistics. And basically, I got this question from check.com, which is an online tutoring service. So this question is on hypothesis testing. Hypothesis testing. Hypothesis testing. Okay. As you can see from the question, we've been told that the machine produces boards having a diameter of 0.2. All right, so we're doing hypothesis testing. The question reads, a machine produces boards having diameter of 0.2 to determine whether the machine, to determine whether the machine is in proper working condition. A sample of 10 boards is chosen from the mean diameter, which is 0.3, and the standard deviation, which is 0.02. Test the hypothesis that the machine is in proper working order using the significance level of 0.01. All right, so basically there are two I would say two types of hypotheses that we need to know of, even as we start this question, right? The first type of hypothesis that we should know of is the null or the null hypothesis. Which is just basically, actually, null is the short word for nullified. All right, so null is a short word for nullified. So basically, a null hypothesis is the hypothesis that is in line with the claim and is said to be nullified for an alternative hypothesis. So a null hypothesis is an hypothesis in line with a claim that is said to be nullified. Null hypothesis. All right, and usually we are either accepting or rejecting the null hypothesis. So simply we can say the null hypothesis is the hypothesis that we are either going to accept or reject, or the hypothesis that will be nullified for an alternative hypothesis. Okay, so those are the two definitions that you can use. The null hypothesis is just an hypothesis that is said to be nullified, or the hypothesis we are testing to either accept it or reject it. Then the second type of our hypothesis is the alternative hypothesis. Okay, so basically an alternative hypothesis is an hypothesis that is accepted after we reject the null hypothesis. So that is how we can define the two. Null hypothesis, this is an hypothesis in line with the claim that is either going to be accepted or rejected. Okay, then the alternative hypothesis is the hypothesis that we accept when the null hypothesis is rejected. All right, so basically how we set the null hypothesis, we set it in accordance to the claim. Okay, there will usually be a claim, so we need to identify what is the claim that we are trying to test. So when we look at here, a machine produces board. A machine produces board having diameter of 0.2 centimeters. So this is a claim. The machine produces boards having diameter of this. To determine whether the machine is in proper working condition, 10 boards are chosen with the mean diameter of 0.3 and standard deviation of 0.2. So as we can see here, the claim is that the machine produces boards having diameter 0.2. So the diameter, which is so we say the null hypothesis, the machine, okay, the machine, okay, the claim is that the machine produces diameter of this. So the question says test the hypothesis, that the machine is in proper working condition. So if the machine is in proper working condition, then it should produce the mean diameter of this. So our claim is that the null hypothesis is that the mean is equal to 0.2, or the other way we can set the null hypothesis is by saying the machine is in proper working condition. Okay, so we can also say the machine is in proper working condition. Okay, the machine is in proper working condition. Now, what would be the alternative hypothesis? The alternative hypothesis will just be the opposite of this. So we're going to say the mean is not equal to 0.2, meaning that the machine is not in proper working condition. So here you just say the machine is not in proper working condition. Now, what we are either accepting or rejecting is the null hypothesis. All right? So now, when you observe, you have been given the standard deviation and the mean. Okay? You've been given also the sample size. We chose 10 boards, the mean diameter of 0.3 and the standard deviation of 0.2. So let's write down what we have. So from our data, we have the sample size of the boards that were taken were 10. Okay. We also have the population mean, okay, which is the usual production of the machine. So the machine produces boards having diameter of this. So this is a claim. So the population of the machine, or the mean population of the machine, is 0.2. Then we've been given the sample. So number, this is the population that is usually expected from the machine, but from the sample of 10, the diameter was 0.3. So the diameter was 0.3. The mean diameter was 0.3. Okay. The expected is 0.2, but when we took a 10 boards, we found that the mean diameter was 0.3. Okay, and this had a standard deviation of 0.02, like that. Oh, and we are also testing this hypothesis at alpha, which is the level of significance. Alpha equals to 0.01. Okay, so this is how we are taking this test. Now, having this data, you need to know which tool you're going to test with. Okay, so if you have a population mean and a sample mean, standard deviation and the sample size, you can use the Z-score test. So here we're going to use the Z-score test using the score test, z-score test, which is given by z is equal to the sample minus the population over standard deviation over root of root of n. Okay. Then from here we are also going to find z alpha. Okay, which is z alpha, and our alpha in this case is 0.01. Okay, z 0.01. Okay. Now, hope in the next video I can show you how to find the z alpha for 0.01, but it usually differs for different tests. Okay, it usually differs for different tests. We have two categories of tests. There are tests that we'll be doing for two-tailed and for one-tailed. All right. So in this one, we are using the two-tailed test. Using the two-tailed test, by the two-tailed test, z 0.01 is equal to, all right, so for a two-tailed test, z 0.01 is equal to plus or minus 2.58. All right, so now why is it important to find z alpha or z 0.01? Right, it is this that will act as our scale for accepting or rejecting the hypothesis which we are going to determine using this value. Okay, so this is acting as our scale for either accepting or rejecting. So from here, what you do is you draw a normal distribution, because the z-score is normally distributed with the mean 0 for there. Then this is z 0.01, which is positive 2.58. And this side we have z 0.01, which is negative 2.58. All right. So now the thing is, if this value of z that we will calculate here, if it lies in this region here, if it lies in this region inside the z alpha, we will accept the null hypothesis. Remember, we are only accepting or rejecting the null hypothesis. However, if the z value is found outside here or outside here, we reject the null hypothesis. All right. So the z alpha is giving us the scale that we're going to use to either accept or reject the null hypothesis using this equation here. So now let's compute this equation here. We already have our data. All right. This is our sample mean, which is 0.3, minus the population mean, which is 0.2, divided by the standard deviation all over the root of the sample. All right. So we do that. So we now calculate the z-score. The z-score, so the z-score is given by x bar minus the mean all over the standard deviation all over root of n, which is the 0.3, which is the sample mean. Okay, the sample mean is 0.3, the population mean is 0.2, so minus 0.2 divided by the standard deviation. The standard deviation is 0.02. Okay, let me count to check. Yeah, so that is 0.02 and sample size 10. So this is a 0.02 then all over root of 10. So how you calculate? You simplify first the numerator, which will give you 0.1, then divide by. You will work out what is inside here. All right, so when we subtract, we're going to get 0.1. Then working out what is inside here, we get that. Then we divide this by this. We're going to get the Z, which will be 15.11. Then from here, we will need to draw back our tool. Okay, so we need to draw back this tool here that we're using. So let me just start this. Let me copy this. Let me copy this. So we bring our tool down here. Here. Bring our tool down here. All right. So by the two-tailed test, we see that which setting we're going to use. Okay. By the two-tailed test, we see that the Z value or the Z score that was calculated is way above 2.58. So we say this is Z equals to 15.811. Because this is 0, this is 2.58, meaning that 15.811 is way above. So we say, therefore, we reject the null hypothesis. We reject the null hypothesis because our Z value is outside or is in the rejection region. So you say that we reject the null hypothesis because our Z score value is in the rejection region. So now from here, if you reject the null hypothesis, you need to make a decision, right? So you come to the decision, okay? In the decision, if you are rejecting the null hypothesis, it means we accept the alternative, hypothesis. We accept the alternative hypothesis. Now you need to say what the alternative hypothesis is about. So remember when we stated the alternative hypothesis, we said, okay. In the null hypothesis, we said the machine is in proper working condition, meaning that the mean should be constant, which is 0.2. So the alternative hypothesis is that the machine is not in proper working condition. So we go back and we say that right there. So we accept the alternative, then we say the machine is not in proper working condition. In proper working condition. Okay, so that is our decision. So that is what you're going to do. So the machine is not in proper working condition. Let me just run you through the steps that we took. Okay, the step started from here. So we read our question. Then we stated the null hypothesis, which is in line with the claim. So the claim here is that the machine produces bots of diameter 0.02. I don't know if you can see that. Let me zoom in. So the claim is that the machine produces bots of 0.02. The null hypothesis is in line with the claim. Okay? Population should be 0.02. Test the hypothesis that the machine is in proper working condition. So in line with the claim, the machine should be in proper working conditions. So if the machine produces the diameter of 0.02, then the machine is in proper working condition, because this is what we are expecting. So the alternative will just be the opposite of this. And from there, we set our data, okay? Then we set the test that we're going to use. So we're going to use the Z-score because we have the mean, sample mean, we have sample mean, population mean, sample size, we have standard deviation, right? The level of significance is how much or the level of error that we're going to allow to be done in our calculation, right? So using the Z-score test, this is the formula for the Z-score test, but we need to find also Z-alpha, which is connected to the level of significance. And for a two-tailed test, we said Z-alpha, which is 0.01, equals to plus or minus 2.58. Okay, so you work with it by a two-tailed test. So from here we look at, this is the graph. We just interpreted the data for the Z alpha at 0.01. Okay, looking at this, so this is where the positive 2.58 will be. This is negative. The region in between these two values is the acceptance region. Here we have the rejection region. Okay, then we are asked, or we then calculate the Z-score using this. Then we will compare our value if it is going to be inside the region of acceptance or outside the region of acceptance. So that is how you do hypothesis testing.